Good morning, student. Let us see problems in exercise 3.3, question number 2. Second question, evaluate. In that second question, cos inverse of 1 by 2 plus 2 sin inverse of 1 by 2. Very simple question. In short, we can solve this. We know the principal value of cos inverse 1 by 2 is pi by 3. And principal value of sin inverse of 1 by 2 is pi by 6. Therefore, pi by 3 plus 2 into pi by 6. 2 1s are 2 3s are. Pi by 3 plus pi by 3, that is equal to 2 pi by 3. Therefore, answer is 2 pi by 3. But you have to solve step by step, isn't it? Find the principal value of cos inverse 1 by 2. Find the principal value of sin inverse 1 by 2. That is principal value of cos inverse 1 by 2 is pi by 3. Principal value of sin inverse 1 by 2 is pi by 6. Then put the values and get the answer. Very simple question. You can try this. Try yourself. Now third question we will solve here. Tan inverse of, we have to find the value of this. Tan inverse of root 3 minus sec inverse of minus 1 by minus 2. Solution. Let tan inverse of root 3 is equal to x and sec inverse of minus 2 is equal to y. Therefore, here we get tan x is equal to root 3 and here we get sec y is equal to minus 2. Isn't it? Now, tan x is equal to tan of pi by 3 and sec y is equal to minus sec pi by 3. Sec pi by 3 is 2, isn't it? Here we get x's get cancelled, x is equal to pi by 3. Principal branch value of tan inverse is minus pi by 2 to pi by 2. Here minus pi by 2 is less than pi by 3 is less than pi by 2. Therefore, tan inverse of root 3 is equal to pi by 3. Now here we will solve. We know that minus sec theta is equal to sec pi minus theta. Therefore, minus sec pi by 3 is equal to sec pi minus pi by 3. Minus sec pi by 3 is equal to sec 2 pi by 3. Isn't it? Therefore, sec y is equal to minus sec pi by 3 is equal to sec 2 pi by 3. Therefore, sec y is equal to sec 2 pi by 3. Sec get cancelled. Y is equal to 2 pi by 3. Also, we know that principal branch value of sec inverse is 0 to pi minus pi by 2. Here 0 is less than 2 pi by 3 is less than pi. Therefore, sec inverse of minus 2 is equal to 2 pi by 3. Isn't it? Now, tan inverse of root 3 plus sec inverse of minus 2 is equal to pi by 3 minus 2 pi by 3, that is equal to minus pi by 3, that is equal to pi minus 2 pi upon 3. Therefore, tan inverse of root 3 plus sec inverse of minus 2 is equal to minus pi by 3. Answer. In this way we can solve this question. Isn't it? Very simple question. Let us see fourth question. Question number 2. Evaluate. Cosec inverse of minus root 2 plus cot inverse of root 3. Solution. Let cosec inverse of minus root 2 can be written as sine inverse of minus 1 upon root 2. We know this. And cot inverse of root 3 can be written as tan inverse of 1 upon root 3. Now, let sine inverse of minus 1 upon root 2 is equal to x and tan inverse of 1 upon root 3 is equal to y. Therefore, sin x is equal to minus 1 upon root 2. Sin x is equal to minus sin pi by 4. Therefore, sin x is equal to sin minus pi by 4. And here minus 1 by 2 is less than minus pi by 4 is less than pi by 2. Therefore, sin inverse of minus 1 upon root 2 is equal to minus pi by 4. That is, cosec inverse of minus 2 is equal to minus pi by 4. Now, here we get tan y is equal to 1 upon root 3. Therefore, tan y is equal to tan of pi by 6, 30 degree. Tan 30 degree is 1 upon root 2. Therefore, y is equal to pi by 3. Here, minus pi by 2 is less than pi by 3 is less than pi by 2. Therefore, tan inverse of 1 upon root 3 is equal to pi by 3. Therefore, cot inverse of simply root 3 is equal to pi by 3. Now, cosec inverse of minus 2 plus cot inverse of root 3 is equal to minus pi by 4 plus pi by 3. That is equal to minus 3 pi plus 4 pi upon 4 into 3. That is equal to pi upon here 1 upon root 3 is the value of pi by 6. Instead of pi by 3 we have to write pi by 6. Pi by 6, pi by 6 here, pi by 6. Since tan pi by 6 is equal to 1 upon root 3. Keep in mind. Therefore, here instead of pi by 3, pi by 6 will come. Here 6 pi. Here 4 into 6 will come. Minus 6 pi plus 4 pi upon 4 into 6. That is equal to minus 2 pi upon 24. That is equal to minus pi upon 12. Therefore, cosec inverse of minus root 2 plus cot inverse of root 3 is equal to minus pi upon 12. Answer. Here I have made mistake. Tan pi by 6 is equal to 1 upon root 3. Therefore, instead of 1 upon root 3, we can write tan pi by 6, not pi by 3. Isn't it? In this way, we can complete question number 2. Isn't it? Let us see exercise 3.3, question number 3. Prove the following. First question, sine inverse of 1 upon root 2. There in exercise minus 1 upon root 2 is given, but that is there is a correction. It required sine inverse of 1 upon root 2. Instead of minus 1 upon root 2, we have to write plus 1 upon root 2 minus 3 sine inverse of root 3 upon 2 is equal to minus 3 pi by 4. Isn't it? Correction. Here correction is there. Huh? Solution. Let us solve this question. Let sine inverse of 1 upon root 2 is equal to x and sine inverse of root 3 by 2 is equal to y. Therefore, sine x is equal to 1 upon root 2 and here sine y is equal to root 3 by 2. Therefore, sine x is equal to sine pi by 4. Here sine y is equal to sine pi by 3. Sine 60 degrees root 3 by 2 and sine 45 degrees 1 upon root 2. Isn't it? Therefore, sine get cancelled. Here x is equal to pi by 4 and here sine get cancelled. Y is equal to pi by 3. We know principal branch value sin inverse is close interval minus pi by 2 to pi by 2. Here minus pi by 2 is less than pi by 4 is less than pi by 2. Also minus pi by 2 is less than pi by 3 is less than pi by 2. Therefore sin inverse of 1 upon root 2 is equal to pi by 4, and sin inverse of root 3 by 2 is equal to pi by 3. Consider LHS is equal to sin inverse of 1 upon root 2 plus minus 3 sin inverse of root 3 by 2. That is equal to, put the value, pi by 4 minus 3 into pi by 3, isn't it? That is equal to 3 get cancelled, pi by 4 minus pi, that is equal to pi minus 3 pi upon 4, which is equal to minus 4 pi. Cross multiplication, 4 pi minus 3 pi upon 4, which is equal to RHS. Hence proved. In this way we can prove these questions, isn't it? Remaining questions we will see in coming video, isn't it? Very simple question.